are going to be working on 3C today, and this is on dilation. Now, some people do struggle with dilation, so I'm going to break it down more than I would normally, just to give you an understanding of how it works and how it's applied. I'm just going to go over some theory before I go over some examples first. So dilation, the focus is about resizing. So when I say resize, it's talking about stretching or away from the X and Y axis, or it's looking at compression, getting closer to the X and Y value, axis, sorry. So that just means that it's a scale factor. It will change the shape of the graph, but it's still going to be similar. It's going to be in proportion. So another way of thinking about it is we've got our k value next to our x and our next to our y. So that's what's really happening to our graph. So if we talk about vertical dilation, so first thing it means by vertical dilation is it is being pushed up. So another way of thinking about it is we are starting at the x axis, and we're pushing away from that. So if we are pushing away from the x-axis, what is actually changing? The x value stays the same. But if we're pushing away, it's the y value that is changing. So it will either get taller, pushed out, stretched, or will get flatter, and we call that compression. So another way of thinking about that in terms of this graph is that our x and the new x value stays the same. It's the y value that is going to change. So whatever our y value was would be times by the scale factor of k. Another way we can write this is having our f of x and putting a out the front. And we're saying that that a, if it's greater than 1, it's going to be stretching because, of course, if we times it by 2, 2 times something will be a lot bigger. If it's less than 1, it will be a decimal, which means that it is going to compress towards our x-axis. Likewise, horizontal dilation. So if we're talking about the horizontal, it's the opposite. It's, it's, it's going to be pushing away from the y-axis. So when I say pushing away, I'm stretching away from the y-axis. That means instead, our y value is staying the same, but our x value is being multiplied. So, and this is where we can look at this and say our y value is the same, but it's the new x value that is being changed. Whatever our x value was before, we are timesing by k. Now, I know I'm just going to get a highlighter. This is the part people just assume. Whatever value you're given as your scale factor, you're just placing it in front of that x, and that's what's happened. But the reason why it works with the y is because y is always out the front, so we know what y is actually equal to. So be mindful of that. That is just something that I will be going into in more detail, because there's a misconception there that a lot of people do struggle with. So let's go into more detail. So for instance, another way we are able to write this is it's actually going to be putting x over k. And I'm going to be talking about this in more detail. So be patient with me. So let's look at this next slide. So I'm just going to do this both visually, and I'm also going to do this just with the equation and understanding it. So what we said before when we've got this rule, y equals 1 over x minus 2, we've got it's saying it is dilated by a factor of 2. And we're talking about the x-axis here. So if we're talking about from the x-axis, it means we're stretching away from the x-axis, so the y is being affected. So we're going, the x stays the same, the y is what's changing. So This is easy because in this one here, we already know, I'm just going to highlight what y is equal to. So whatever this is, we are just timesing by 2. We can simplify that, of course, and we get y is equal to 2 over x minus 2. The next part, if I look at graphing this, our original here is y equals 1 over x minus 2. And I did these graphs in decimals to make my life easier. And here I've got the new graph. So let me change to a pen. So what we can see here is, as I said before, we are going to be stretching away from the x-axis. So this here has been times by 2, and this -1 has turned into -2. So as I said before, this graph is visually showing it. Now, when we're looking at the same dilation by a factor of 2, but we're doing it from the y-axis this time. If we're doing it from the y-axis, the first thing I want us to think about is that it means, and I'm just going to do it through the rule first. This part here just means that we're going to be x over 2. So that's what we're substituting in. I'll explain why in a minute. The next part is I'm just going to simplify this. So that just means I made this 2 to be 4 out of 2. So I could rewrite it as 1 over x minus 4 over 2. The final part is keep change flip, and that got me y equals 2 over x minus 4. So if we look at this with our graph, this is what the graph looks like. Now, I did say when it says from the y-axis, it means our x is changing. So all we've done is we're pushing it out, and we can see that. Here we were at -1, and now I'm at 2. I used a highlighter instead of an arrow this time. Now, let's talk about why this works, because it's always from the y-axis that everyone has trouble with. So let's start off with our basic graph. Now, even if you've got f of x, you can just write it with y for this to make it easier. Now, the first thing I'm going to do is, because we're talking about the change of our x value, let's just get x by itself. So I will times both sides by x minus 2. I will divide by y and plus 2. Now I've got x by itself. So if the x value needs to have a factor of 2, this is what x is worth. This is the new x. Now, the reason why I'm focusing on that, I'm not going to do much more than what I've done here on this. But the key part is, if I want to get rid of that 2 to get it back into the normal equation, it's going to be x is over 2. That's the reason why it was written as x over 2. But sometimes it's easier for us to show you in this form for you to see it yourself. Let's have another go. So this time we are going to determine the rule of the image when the graph of y is equal to x plus 1. So y is equal to square root of x plus 1. So the first part is the dilation by a factor of 4. Now, we've got from the x-axis. So when I say from the x-axis, I'm meaning I'm stretching up. So I'm stretching up, the x value stays the same, but the y value is changing. So all that means is I've got my y value up here. So I'm just putting my factor of 4 on the outside because I know what y is worth. And then I simplify that. So I've got y is equal to 4 square root x plus 1. If I look at the first original graph and then I look at the second graph, we can see that it's gone from 1 all the way up to, oops, well, I don't know why it's doing that, all the way up to 4. So 1 times 4 is 4. That's the point is probably the easiest to show. Likewise, let's look at the second one. So when we're talking about dilation factor from the y-axis, it means we are pushing it out, which means the x value is being affected. Now, I said before that we know the dilation of our x, of our new x, is 4, it's not going to be, we're just plugging in a 4. It means it will be x over 4 in the equation. I can check this. So here I've done it incorrect to show you what happens. So if I just put a 4 here, it's getting compressed. Here shows you how it should be, and it means that it's being pushed away, stretched away from the y-axis. If I do the calculations, I'm just going to start off with y equals square root x plus 1. I will square both sides, and I will take away 1. Now, if I do this and just put a 4 out the front, if I wanted to transpose it back to getting y by itself, now I know what x is worth, I am going to end up getting x over 4, which is the reason why I had written it as x over 4 in here. So we just need to make sure we understand that and remember that part. Oops, unfortunately, I have my part of my graphics. So I'm just going to pause this video. Okay, so let's look at this next question now. We've got 4 y equals f of x, which is equal to 1 over x. Sketch the graph of each of the following. So the first part that we are going to look at, where is this, is what does it mean when we've got 3x here? So it's referring to a horizontal compression. So let's have a look at this. So the first thing that I'm going to do here, I'm just going to go down to the bottom, is we know our original x value needs to be times by 3. So whatever our x value was. Now, in this case here, the first thing that I'm going to do is I'm just going to get that new x value by itself. So that new x value will turn into x over 3. So then what I'm wanting to happen is it's going to turn into x over 3. That's my new point. I'm going to write it with the equation by substituting the 3x in. And it's going to turn into y is equal to 1 over x. So 1 over 3x. Let's look at this in terms of the graph. So if I just draw these now, first thing I want to show you is our original graph. If x is 1, y is 1. So that's this original graph I've highlighted in yellow. If I go to green, what you're going to notice is here, we said our new value will be a third, and that's exactly what's happened. Our new value now is going to be over here, which is our x is 0.33. Our y value has stayed identical. So we can see that there is that horizontal compression. So now if we look at it in terms of y equals 4 f of x, the 4 is on the outside and it's showing us that there's going to be that vertical stretch right there. So whatever our y value was, we're timesing it by 4. So I know my y value, 1x, so I'm just timesing that by 4. and simplifying that to 4 over x. So if I just draw those two graphs, and there's no translation here, we're just looking at dilation, we can see that it's pushed up my graph from 1 to 4. Likewise here, -1 to -4. So we can see that there is that stretch going on. Let's look at the next couple of questions. So the first part here is we are going to look at y equals f of x is equal to x to the power of 3, and we're going to sketch the graph of each of the following. So we've got half, y equals half f of x. So straight away, because this number is less than 1, it's going to be a compression. The number is on the outside of f of x, so we're talking about a vertical adjustment. So with the vertical compression, that means whatever my y value was, I'm halving it. So I can rewrite my equation as y is equal to x to the power of 3 and halving it, so dividing by 2. If I put those on there, we can see that it changed and it's getting closer to it's getting closer to my x-axis. Likewise, if we look at y equals f in brackets 5x, straight away we know it's dealing with the horizontal because it's affecting the x. And we also know that it's going to be compression. Because remember how we think about it on what we did before. So same thing as what we're applying, but I'm just not doing all the working out now. So straight away with the horizontal compression, I'm literally just going to work it out by writing my equation with 5x into it. Now, that also means that my x, to get my new x by itself, I'm just to get my new x by itself, I'm going to have to divide by 5, which means it's going to be my new x is going to be x over 5, which is what we talked about before. So I'm just going to write that down as what is happening to it next. And the next part is I'm just going to graph it. So we can quite easily see that compression going on. It's getting closer to my y-axis. We've got a couple more questions, and this is just making sure that we're going over everything that you'll need. So this part here is now just stating what is the transformation which maps the graph of y equals f of x to the new graph f1 of x. So we've got a 3 up the top. So straight away I know I'm just going to write it down. I like to rewrite it sometimes just so we can have a look. So realistically, that would have been 3 on the outside and 1 over x squared. So that means whatever my y was worth before, I have just wanted to times it by 3. So that helps me because it means I know on what is occurring and what is my scale factor. So I've got 3y, so which means I've got a vertical dilation by a factor of 3 from the x-axis. Likewise, if I look at my new graph for b, f of x is saying is equal to square root x, and my new graph is f1x is equal to square root 2x. So straight away, I know I'm talking about this horizontal dilation, but it's, as I said before, because it's a number here next to x that is bigger than 1, it is going to be a compression. So we always need to think about that as in terms of our current x value, whoops, To get our current x value to be equal to new, our new x, what do we need to do to it? It means I just have to divide the x value by 2. So this part is going to help us out on the next part where we're looking at what that looks like. So now, after we've done this, I'm just going to write down on what's actually occurring, and we do have a horizontal compression of factor of 2 from the y-axis. Okay, we've got 2 more questions I want to go over. So, state a transformation for which maps the graph of y equals f of x to the graph of y equals f1x. So, first thing I'm going to look at is what is occurring. So straight away here, I've got x over 3. So I'm just going to highlight that. So straight away, because it's affecting the x, I know it's going to be looking at its horizontal dilation. Now, because it's dividing by 3 here, I also know it's, if we think about this graph, when we've got a value in front of the x that is small, it's decrease that value, which means it's going to push it away from the y-axis. So we've got a horizontal dilation by a factor of 3 from the y-axis here. Likewise, when we're talking about our B question, it's got f of x is equal to square root x plus 4, and f of 1 is x is equal to 2 square root x plus 4. The part that changed between these two graphs is the 2 on the outside here. So that means whatever our y was, which was square root x plus 4, we are just timesing it by 2. So straight away here, I'm just timesing it by 2. Which means we can say it's a vertical dilation by factor of 2 from the x-axis. Now, even though I have just done it this way, I'm going to add in one extra part and going back to A quickly. So if you get confused on what does that divide by 3 actually mean, just rewrite it. So I'm just going to rewrite it as y is equal to x over 3, and I'm going to square root the y. And then straight away, I then am going to get x by itself. So I'm going to take the 3 onto the other side. So I've got 3 square root y is equal to x. So straight away here, it shows me that that divide by 3 is just meaning whatever my x value was originally, I am going to be timesing that value by 3, which is this part here. And which is why we talked about when it says that, it is going to be divided by in the equation. So it's really about understanding that key relationship between these two parts.